Johannes Kepler was born in Germany in 1571. He was sent to the Protestant seminary school in the provincial town of Maulbronn to be educated for the clergy. He lived in a time when the human spirit was fettered, the mind chained. Science still lacked the slightest notion of physical laws underlying nature. But the brave and lonely struggle of this man was to provide the spark that ignited the modern scientific revolution. There were only 6 planets known in his time. Kepler remembered the perfect solid of Pythagoras. He believed that the 2 numbers were connected, that the reason there were only 6 planets was that there were only 5 regular solids, and this connection between geometry and astronomy could, he thought, admit only one explanation: the hand of God, mathematician. But no matter how hard he tried, the perfect solids and the planetary orbits did not agree with each other very well. He decided that it must be the long-accepted planetary observations that were inaccurate, and not his model of the nested solids. There was only one man in the world who had access to more precise observations. That man was Tycho Brahe. Tycho was the greatest observational genius of the age, and Kepler the greatest theoretician. The birth of modern science, which is the fusion of observation and theory, teetered on the precipice of their mutual distrust. Kepler tried various oval-like curves, calculated away these arithmetical mistakes, which caused him, in fact, to reject the correct answer. And months later, some desperation, tried the formula for the first time for an ellipse. The ellipse matched the observations of Tycho beautifully. When a given planet is at the far point in its orbit from the Sun, it goes more slowly. As it approaches the near point, it speeds up. Kepler's first law of planetary motion is simply this: a planet moves in an ellipse, with the Sun at one focus. As the planet moves along its orbit, it sweeps out, in a given period of time, an imaginary wedge-shaped area. Although the shapes of these wedges are different, Kepler found that their areas are exactly the same. Kepler's second law is this: a planet sweeps out equal areas in equal time. Kepler's third law states that the squares of the periods of the planets, the time for them to make one orbit, are proportional to the cubes, the third power, of their average distances from the Sun. So the further away a planet is from the Sun, the slower it moves, but according to a precise mathematical law. This confirmed his long-held belief that there must be a force in the Sun that drives the planets, a force stronger for the inner fast-moving planets and weaker for the outer slow-moving planets. Isaac Newton later identified that force as gravity, answering at last the fundamental question: what makes the planets go? Kepler was the first person in the history of the human species to understand correctly and quantitatively how the planets move, how the solar system works. He imagined a journey to the moon, the space travelers standing on the lunar surface, looking up to see rotating slowly above them the lovely planet Earth. Really believed that one day human beings would launch celestial ships with sails adapted to the breezes of heaven, filled with explorers who, he said, would not fear the vastness of space. Before Kepler, astronomy had little connection with physical reality. But with Kepler came the idea that a physical force moves the planets in their orbits. first to combine a bold imagination, precise measurements, to step out into the cosmos. It changed everything.